Okay, class. So there are four properties of arithmetic mean that we must keep in our minds. So I'm going to introduce all the four properties. So let us look at the first property here. So first property says, property number one, first property says, if all the observations assumed by a variable are constants, all the observations are same, they are not changing, and say k, then the arithmetic mean is also k. Yes. So let us take an example. Let us say that there are 5 students in a class, and all these students they scored 75 and 75 and 75 and 75 and 75 in maths. Okay, all of them scored 75 in maths, all 5 of them. So what is the arithmetic mean is the question. So according to this particular property, it says that arithmetic mean, because all the numbers are same, the arithmetic mean should also be the same number, which is arithmetic mean according to this is 75 according to this property. Whether it is 75 or not, we can find that out. So we will write a 75 plus 75 plus 75 plus 75 plus 75, and all of that, as per the definition, will be divided by 5 because there are 5 number of observations. Now 75 is 5 times, so it can be written as 75 into 5 divided by 5. So 5 cancel, 75. So it is not only true with 75. Let us say it was k. So I would say k plus k plus k plus k plus k. This time 6 observations. So I have added them 6 times. So I have to divide that by 6. So am in this particular case is k into 6 divided by 6. Right? Answer is k. Easy. So the first property of arithmetic mean is that if all the observations have the same value, even the arithmetic mean is the same value. Okay, good. So let's look at the second property. And the second property says that the algebraic sum of second property out of 4 says that the algebraic sum of deviations of a set of observations from the arithmetic mean is 0. So algebraic sum of deviations. We are talking about deviations. Let us find out what is meant by deviation. Suppose there are numbers called 5 and 10 and 15 and 20, and let's say 25. So there are 5 numbers, 5, 10, 15 and 20, 25. Okay. So what it is saying is that algebraic sum of deviations of a set of observations from the arithmetic mean is 0. Okay. So for unclassified data, xi, which is the number minus arithmetic mean, if I calculate for all the numbers and I just add them, it will be 0. Similarly, for grouped frequency distribution, frequency multiplied by xi minus x bar, which is the arithmetic mean, should be the summation of all should be 0. So let us take this particular example and find out what is the arithmetic mean. So arithmetic mean here, for that, according to the definition, we have to add all the observations and we have to divide by the number of observations, which is 5. Okay, so 5 plus 10, 15, 15 plus 15 is 30, 30 plus 20 is 50, and 50 plus 25 is 75, so 75 by 5 is 50. Okay, so let us calculate xi minus x bar. So xi minus x bar, xi minus x bar. X bar is 15, xi in this particular case is 5 minus 15, so minus 10. Similarly, in the case of 10, xi is minus 5. In the case of 50 minus 15, xi is 0, and xi minus x bar is 5 in the case of 20. When xi is 20 and 25 minus 15, I am calculating, I am getting 10. So the question is that if I add all of these are the deviations, right? We have to add 10 minus 10 minus 5, 0, 5, 10. If I add all of this, the answer is 0. So the deviations from average, okay? So deviation from average is how much? Xi minus average. Whatever is the number minus the average value. If I do that for all the numbers, some I will get minus, some I will get plus. If I do that for all the numbers, when we add all of that deviations, the total result will be 0. That is the second property of arithmetic. Okay. Easy? Okay, so let us look at the third property. Now the third property, you don't need to understand the mathematics of it. I just want you to explain that if, you know, y is equal to a plus bx is given and x bar, which is the average value of x set of observations, the average value is given, then y, the average value of y is going to be a plus b average value of x. If y is equal to a plus bx, then average value of y is also equal to a plus b average value of x. That is as simple as that. Now, it says that, let us look at it. This is the third one. Arithmetic mean is affected due to a change of origin and or scale, which implies that if the original variable x is changed to another variable y by effecting a change of origin, say a, and scale say b of x, that is y becomes now new y becomes a plus bx. Now this is all mathematical. Change of origin. So if you take one number and then you add some constant, then origin shifts. I don't want you to go into the detail there, okay? Similarly, scale changes when you multiply a number x by some number. The scale will change. Because if I say that y is equal to 2x, then if x is 2, y is 4. If x is 4, y is 8. So if you look at y is changing double the speed, at double the speed of x. So scale is changing, that's what they say. But forget about this scale change or origin change. Just remember that if there is an equation y equal to a plus bx, which is being followed for all the observations, then the arithmetic mean of y can be found out if we know the arithmetic mean of x. And if y is equal to a plus bx, then arithmetic mean of y is equal to a plus b arithmetic mean of x. As simple as that, there is nothing else to it, okay? Now, so let's take an example. So I can take one example here as, let us take a distribution 2x plus 3y plus 7 is equal to 0. Okay, so if we take 2x plus 3y plus 7 is equal to 0, and if x bar is given, which is the average value of x is given, okay, so let us say that average value of x is given as 50. If average value of x is given, then what is the average value of y is the question. So let us just find out what is y. So y here is minus 2x plus 7 divided by 3. That is y. So y bar, according to this property, y bar is equal to minus 2x bar plus 7 divided by 3, which is minus 2 into 15 plus 7 divided by 3. So 2 into 15 is 30 plus 7 divided by 3. So minus 37 divided by 3. Okay, which if you calculate is minus 12.33. Right, so simple. There is nothing, complicated here. I just used the simple equation y is equal to a plus bx and 2x plus 3y plus 7 equals 0. So I use the equation y is equal to minus 2x plus 7 divided by 3. That's it. And then I just replaced, when I had to calculate y bar, which is the average of y, I just replaced x with the average value and we found out what is the average value of y. It's very, very simple. There is nothing complicated with this property. So now the fourth property, and I think you can be asked a question in the fourth property. So let us just look at the fourth property quickly. So fourth property says that if there are two groups containing n1 and n2 observations, two groups are there, one group, two group. This group has n1 observations and this group has n2 observations. Okay. And the average arithmetic mean of this group is x1 bar and this group is x2 bar. Okay. And if we are asked to find out the combined arithmetic mean, then it is given with this formula. You multiply n1 into average of first group x1 bar. And you add that with n2 number of observation multiplied by x2 bar, which is the average of the second observations, second group. And after that, you divide with the total number of observations. As simple as that. So n1 x1 bar plus n2 x2 bar divided by n1 plus n2. If there are more such groups, such as there are three groups, let us say, and this one n1 observations, n2 observations, n3 observations, and this one is x1 bar is the arithmetic mean, x2 bar is arithmetic mean, x3 bar is arithmetic mean. Then what is the combined arithmetic mean? So that can be found out by saying n1 x1 plus n2 x2 bar plus n3 x3 bar divided by total number of observations. Okay. Now this whole thing can be represented like this. If there are multiple, you can say that summation of ni xi bar divided by summation of all ni's. That's it. So it holds for two groups, it holds for n groups, it holds for as many groups as possible. If number of observations is given and average value is given, no problem. And if you are asked to calculate the combined arithmetic mean, you just use this particular property. Okay, so one example we'll quickly solve. The mean salary for a group of 40 female workers is 5,200 per month, and that for a group of 60 male workers is 6,800 per month. What is the combined mean salary? So there is one group here which is a female group, and n for this is given as 40, and salary, average salary, let us say, is given as 5,200. Another one is male, and here is given as 60, and average salary here is given as 6,800. Fine. So what is the combined? So combined thing, we'll say a salary combined is equal to, let's say, n1 s1 and n2 s2 is the total number of observations multiplied by the mean plus total number of observations multiplied by the mean salary divided by total number. Total number of observations is 40 plus 60. So 40 into 5,200 plus 60 into 6,800 divided by 100. Okay. So what is 40 into 5,200? We'll just do that simple maths here. 4 into 2 is 8. 4 5s are 20. And then how many zeros? 3 zeros. This one, 6 into 8 is 48. 6 into 6, 36. 36 plus 4, 40. And 300. That's whole thing divided by 3 zeros. Whole thing divided by 100. Fair enough. So let's just add now. So 8 plus 8 is 16. 1. 4 plus 2 is 6. 6 1 6 0 0 0 divided by 100. So it's rupees 616. Okay. So that is the arithmetic, combined arithmetic mean in this particular case. Very, very simple property. If there are two or more groups given, and if the number of observations of each of the groups are given, the arithmetic mean of each of the groups are given, the combined arithmetic mean is very easy to find, and we can use this formula to find combined arithmetic mean. That's it. So this is how much we need to know about mean. Now let us go ahead and find out what is median. Okay.